Okay, so it's just a simple limiting reagent problem. It's a variation on the silver nitrate one we did for homework. Okay. And I was nice enough to write a balanced equation for you. So aluminum and copper 2 sulfate make aluminum sulfate and copper. Okay, the first thing you have to do is recognize that it's a limiting reagent problem. That's the first thing you have to do. And the way you recognize it's a limiting reagent problem is they told me grams of aluminum, and aluminum was a reactant. And they told me grams of copper 2 sulfate, and copper 2 sulfate was a reactant. So they told me about 2 reactants. As soon as they tell you about 2 reactants, you know you have to decide which one you're going to run out of first. And the way we do that is we figure out which one makes the least amount of product. Okay. So I'm going to take my 10.3 grams of aluminum, and I'm going to take my 51.7 grams of copper 2 sulfate. And I'm going to turn them both into copper. So I want to get rid of grams of aluminum, change it to moles of aluminum. 1 mole is 26.98 grams. Then I'm going to change moles of aluminum to moles of copper. And mole to mole, we use the coefficients. So in front of aluminum there's a 2, in front of copper there's a 3. And then I'm going to get rid of moles of aluminum, moles of copper, and change it to grams of copper. I look up copper on the periodic table, it says 63.55 grams. So if I push all those buttons, 10.3 divided by 26.98 times 3 divided by 2 times 63.55, I get 36.4 grams of copper. That might be my answer. I need to get rid of grams of copper 2 sulfate. Change that to moles of copper 2 sulfate. And 1 mole weighs 63.55 plus 32.07 plus 64. Doesn't help if you multiply. You get 159.62. Then I want to get rid of moles of CuSO4 and change it to moles of Cu. That's 3 and 3 out of my balanced equation. And then moles of Cu to grams of Cu. And 1 mole is 63.55 grams. .6 grams of Cu. So, how much is produced? 20.6, 36.4, 15.8, or 57.2? The answer is the 20.6. Because I'm doing my reaction, when I hit 20.6 grams of copper, everything stops. Because I've run out of copper in my solution. My solution is no longer blue. All the blue has gone out of it. Okay. How much excess reagent remains? Well, what was the limiting reagent? It's the same equation, so I'll just answer. Well, same question. What was the limiting reagent? It was the CuSO4. It stopped because I ran out of CuSO4. The amount of CuSO4 controls the reaction. Okay. So I start my problem with the 51.7 grams of CuSO4. Once I know that controls the reaction, I want to start all my stoichiometry problems with it. I want to get grams of CuSO4 and change that to moles of CuSO4. 1 mole is 159.62 because we just figured that out. Then get rid of moles of CuSO4. What do I want to turn it into? Well, they asked about excess reagent. What is the excess reagent? It's aluminum, so I want to change it to aluminum. And it says 2 moles of aluminum for 3 moles of CuSO4. And then moles of aluminum to grams of aluminum. 1 mole is 26.98 grams. So 51.7 divided by 159.62 times 2 divided by 3 times 26.98 equals 5.83 grams of aluminum. And you circle that. And Mr. Green marks it wrong. So why'd you mark it wrong? That's the excess reagent. It's grams, it's mass, but it's not grams of excess reagent that remains. That's grams of excess reagent used. I used that 5.83 grams of aluminum. To find out how much is left, I have to take the 10.3 grams that I started with and subtract the 5.83, and that gets me 4.5. No, sorry, 4.7. So I got 4.7 grams of Al left over. Okay. Which of the following is not true about limiting reagent? They all look so good, don't they? One is seriously wrong, though. Which one is it, Michelle? Yeah, B is wrong. We don't know because it could be the smallest weight, but it could be the lightest element. So you'd have a lot of moles of it. Like, I mean, a couple grams of iron is a small percentage of a mole. A couple of grams of hydrogen is a mole. So you can't just look at the weight. You got to do that. Okay. Hey, I want to show you, the book also teaches you a different way of doing this. It's called the ratio method. Okay? And what you do is you compare your reactants, the ratio of your reactants between actual and from the equation. So if I see a question like this, if you start with 7 moles of propane and 7 moles of oxygen, how many moles of carbon dioxide would you produce? Well, according to my equation, for every mole of C3H8, I'm supposed to have 5 moles of O2. Right? My actual ratio is 7 moles of O2 for 7 moles of C3H8. Is my actual ratio too big or too small? Well, 7 over 7 is 1, right? 5 over 1 is 5. So this is too small. Okay? How do you get a number that's too small? Your denominator's too big. That's too big a number. The reason why it's too big is because it's excess. So I can look at that and say, hey, I am going to run out of C3H8. Sorry, I'm not going to run out of C3H8. I got way too much of it. My ratio is too small, so my denominator's too big. I got too much of my excess reagent. Okay? And that tells me if I got too much of my excess reagent is C3H8, then my limiting reagent is O2. Or you can actually see that up here, that I use, in moles, I use my oxygen 5 times as fast. See how that equation says I use it 5 times as fast? So if I start off with equal amounts, I'm going to run out of oxygen first, because I use it 5 times faster. So there's ways of arguing for the excess reagent without having to set up the whole problem. If it's in moles, you can't do it in grams. You can change those grams to moles and then do this comparison. So when you see the book doing ratios, that's the way I learned it. The way I learned it was take the ratio in the equation to the ratio of what you actually got and see which one's too big. The one too big is the one that's excess, so the other one is the limiting. Does that make sense? Yeah. But that's me talking about them. The way you get better at them is for you